Good evening, everyone. It is our privilege to extend a warm welcome to Dr. Surendra Singh, Mathematics Facilitator at Sanjay Ghodawat International School, Maharashtra, who has joined as a esteemed resource person for our IIT Jam lecture series organized by Department of Mathematics, Wilson College, Mumbai under the DBT Star Strengthening Scheme. This series is greatly enriched by your valuable presence, sir. With a strong academic interest in abstract algebra, sir will be leading insightful sessions on the subject. We are truly honored to have you with us today, sir, and we hope that students take maximum benefit from your sessions. So, over to you, sir.
Thank you, ma'am, for the nice introduction. Ma'am, here all the students will switch off their videos and just and mute also, and then I have to teach. Is it like that? Means,
No, they have the freedom to switch on their video and also unmute themselves.
uh, okay. So, good evening, students or friends or aspirants.
Good
Are you
evening,
there?
sir.
Good evening,
Are you
sir.
there? Good evening, or you can type the message also. So,
Good evening, sir.
myself. Good evening. So, my name is Surendra Singh, and as ma'am already given the introduction, so we will learn group theory. Okay. So group, have you gone through the preliminaries which I have sent?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. S- Okay. So you know all about the syllabus and also the paper pattern, right? Exam
Yes,
pattern. You
sir.
have exam.
Yes, sir.
So this time IIT Jam exam will be conducted by IIT Bombay. Correct. Previously it was Delhi. So without wasting time, let's start. So the section 3 is algebra. In that algebra is algebra divided into two part: linear algebra and abstract algebra. In abstract algebra, you have only group part. We don't have ring theory. So only group part we will discuss. So let me share the screen. Okay. So I hope the screen is visible to you, right?
Yes, sir. It's visible.
Okay. So the group theory, the question in 2025 and 2024, if you see, the total algebra question was about 35-36 marks. So in 2025, it is 35 marks question, out of which 15 marks from group theory and means abstract algebra, and linear algebra was 20 marks. You can analyze the question paper of 2025, and even in 2024 also 15 marks the question from the group theory. So you can see the out of 100, 15% the topic which we are covering in this four lecture. Algebra reanalysis, the other part is there, right? So let's go ahead. So and for today is we will see the basic definitions, and most probably I want from you, if you know this, then we can go ahead for the solving the questions. Okay. So what is group? First, the definition is a group is a set in which we have some operations, and that operation satisfy this four properties: closure, associativity, identity element, and inverse. Closure means if you operate with these two elements A, B, then the new element which we got, it should be in the group. Correct? So the question is, suppose I have the integer 1, 2, 3, 4 up to 10. Is this set with the operation addition is closure property? Means the addition satisfies the closure property, yes or no?
No, sir.
Can you give example?
Sir, as you said, there is 10 elements from 1 to 10. So when we add 8 and 10, we are getting 18. That does
Where,
not belong to Z.
very good, very good. So this is meaning of the closure property. It means two element, then the new element form after the operation, it should belongs to set. You said very correctly 8, 10, even 10, 1. So this is not, this the set does not satisfy the closure property. Correct? And if I extend till all integers, then it satisfies the closure property, because addition of two integer is integers. Correct? So this fourth thing, associativity. Associative means if you operate two element first with the third elements, then it is same as you operate the second two first and then with the operate with n element. So how many of you know the definition of the group? You can give thumbs up. I don't know either how to react in this Zoom, or you can chat like yes, yes, yes. If you know, then we can go ahead. And if you have doubt, then we will discuss in detail this question. I will repeat the question, like how many of us know the definition of group? Only one yes. Okay. So 3, 4 yes. Okay. So if you know the definition of group, can you give me an example which is not a group? The example is in front of us, right? 1, 2, 3, 4 up to 10. This is not a group. Okay? Okay. So now the notion is, if we write G plus, so this is the group under addition. Inverse, we will write A raised to -1. Usually we denote only this. Even if it is additive case, we will use A inverse. So in that, A inverse is equal to -A. Okay, the goal of this lecture, we will understand only order of the group, order of element, cyclic, and the abelian group. And we will see how many abelian groups are there up to isomorphism, and how many abelian groups are up to cyclic groups. Correct? So the example usually comes in the exam, that Z plus under integer, which we have discussed now. With the finite set I tell, but it's not a group, 1 to 10. But if you extend till whole integer, then this is the group under addition. Under addition, rationals, real numbers, complex number are also group. You know what is this Zn plus n, or I can just write Zn plus. Which group it is? You can unmute and you can give the answer also. Instead of typing, you can unmute and please give the answer.
Zn is the set of integers modulo n, that is the remainders
Modulo
that we
n.
get. The remainders that we get when you divide a number by n. That is
Very good. So which element will be there in Z10?
0, 1, 2, dot dot up to n, 9.
9. Very good. Now fourth one is Zn star. It means the modulo under operation multiplication with n. Clear? And
Yes.
last one is, yes. Okay. And the fifth example which we have written here, that R real number minus 0. 1 minute, sorry. Real number minus 0. So we will remove this 0 element from real number. And with multiplication, it forms a group. So what is the problem with 0 here?
Zero has
Invert.
no
Zero has no inverse in set of
No
elements.
multiplied inverse. Very good. Now these are the next 5 groups here. Symmetric group, this we will discuss maybe in the next class, but we should know what is symmetric group. So it is a permutation group. Correct? Alternative group, diagonal group, this is all the examples of the groups. Okay. We have seen some groups are finite. Finite means the elements in that set is finite. Suppose Z10 we have taken, so elements are finite. Z plus integer with the operation addition, it is infinite group. Correct? Now let's have check some question here. Z dot integers under usual multiplication. It is a group, number 1.
No, sir.
2,
No, sir.
3,
No, sir.
why? Third, why not?
Every element will not have inverse.
Which element? Okay. So in multiplication, we will not have every element uh, inverse. Very good. Now order of the group. So order of group means it is a preliminary sections which we have done already, but order which are not there. Order means the number of element in that group. So Z10 has order 10. And when we say Sn, the permutation group has n factorial the order. Infinite group, then order is infinite. Okay? Till here it is clear?
Yes, sir.
Okay.
Yes, sir.
Okay. Order of element. Order of element means you have to operate that element that number of times so that you will get identity element. And that number of operations which we are doing, it should be the minimum or the least number, correct? So if I write here A star some operation A star some operation A, and if I am getting identity, then I will write that order is 3. And in notation form, I will write A raised to 3 equal to identity. And order of A is equal to 3. If we operate this 6 times also, then also I will get identity because of the property of associativity. First 3 I will compute, then it is E. The next 3 I can compute and I will get again identity. Identity. So the smaller number we have to consider. So that is called order of A. The least positive integers which gives you the identity. A raised to n is identity. If does not exist that n, then in the order of that element is infinite. Correct? Now example is Z12. In that with operation addition, the 3 bar, this element 3 has order 4 because we can add 3 plus 3 plus 3 plus 3 4 times and it will give us 12. And under the modulo 12, it gives us 0, and 0 is the identity of this group Z12. Clear? An infinite group, then Z is an infinite group. Here element 1 has an infinite order. Okay. Now this we have to remember here. What is the order of element? So the formula is this. We can write this, that order of element is equal to n divided by GCD of A comma n. I hope we know how to calculate the GDC, right? So this is in the cyclic group. We will see later. So find the order of 7 bar in Z20. Correct? So order of 7 bar in Z20 is 20 only. With this formula, 20 divided by GCD of 7 comma 20, and this is 1 only. Okay. Now one thing we can see here or directly remember this, 7 and 20 are co-prime. So in Zn, if the number which is co-prime with n or GCD is 1, then that number has the same order with the order of the group. And usually it is called generator of that group also. Okay. Is it clear?
Yes, sir.
Okay.
Yes, sir.
So yes, so till here we learn only the basic definition of the group. And now with this, when we introduce 7 bar in Z20, so Z20 is which type of group? It is cyclic group. So we'll now see the definition of cyclic group. The cyclic group is a group which has one element whose order is same as the order of group. Means there should exist one element in A, in G, such that that order is same as order of group, whole group. Correct? Then we will say it is cyclic. And this A, the element A is called the generator of that group. Generator means you keep operating that element up to certain number of times, and when you end up and getting the identity, then that whole set which you got here, it will be same as the exactly G group. So first you take A, then A square, A cube, A raised to 4, and somewhere order of n is identity, order of A is identity, you will get identity. And the same group which you got here, it will be same as G. Maybe the element up to order you write first A and A square, A cube will be present in that group. The order of the element may be different, but the group is same. Clear? So now one thing which we will remember, that infinite cyclic group has two generator. Infinite cyclic group has two generator. It means first it is cyclic group and it is infinite elements. So it has only two generators. That generator is, which we will write here, A and A inverse. Okay? A and A inverse. So this sentence you remember and you write also, that every infinite cyclic group has two generators, A and A inverse. So in Z, we have two generators, 1 and -1. We can say that this 1 and -1 both are inverse of each other. Clear? And Zn has, in this Zn modulo n with respect to addition is cyclic with generator 1. So 1 bar is a generator. It is not like that there are not the other generator. Others are also the generators. And what are all the generator? The element is a generator in Zn. If n, that element, suppose I am taking A, that GCD should be equal to 1. Clear?
Yes,
So
sir.
my question is, how many generators will Z10 have?
The class which are mutually prime to 10. I mean, it is 3, 7, 5,
5 of
1, of
10.
course.
5 of 10. So you can check the formula for directly of 5 of 10. 5 of P is P minus 1. Correct? But it is 5 of 10 is not like 9. So 5 of 10, correct? So what he was listing, some students tell listing the element, that is 1, 3, which is GCD with 10 is 1. Next is
7.
7 and
7
9.
and 9.
9.
This is the generator of this. Clear? Okay. And the third, any group of prime order is cyclic. Any group of prime order is cyclic. So if I say Z17, it is cyclic, or any group G which has order 17, that group it is cyclic. Now fact is every cyclic group is abelian. Now we are jumping to the abelian. Abelian group means where the elements is commute. Commute means A dot B equal to B dot A. Like in Z, 2 plus 3 equal to 3 plus 2. Correct? This operation is commutative. Even A upon, I can say A upon B is not equal to B upon A. In the group, it is not okay, means, but A upon B is not equal to B upon A. It means this two division operation is not commuting. Correct? Okay. So G is abelian. So what we have learned, that every cyclic group is abelian. But every abelian group is not cyclic. Okay, reverse is not true. And you can prove this also. You can take as a homework, or if we have time, then we will prove later. So now, abelian group is commute. A dot B equal to B dot A. So we can see that Z plus R plus Zn plus whatever we have seen till now, it is abelian group. And the where it is not commute, it is commutative. It is a group of permutation group. Can you give one more example where it is not abelian? It is group, but it is not abelian group.
Quaternion group.
Quaternion group, okay. One more. In that I dot J equal to K, correct? Set of matrices that is commute with the multiplication operator, correct? Matrices, easy example. Matrices doesn't commute, right? Multiplication. So
Yes.
this is under multiplication, set of all 2 cross 2 matrix under multiplication, invertible matrix I have to say, so that the inverse should exist. So set of all 2 cross 2 invertible matrices forms a group, but it is not an abelian group. Clear? So some linear algebra properties also we should know. It will come later. Now one theorem, Lagrange's theorem. It says that order of element divides order of group. Correct? Reverse means if some element, see if some number divides order of group, then it doesn't necessary that we should have element whose order is that. Suppose is 10. Group of order is 10. Order of G is 10. Then if suppose 5 divides 10, it's not suppose like 5 divides 10. But we may not guarantee that there will be element in this group whose order is 5. Clear? But if we have element whose order is 2, then like 2 divides 10, it is true. So how we can use this? We can use this in this way. If we know the order of group, correct, then you can check the possible order of the element in that group. So like we have 10, so we can check that element must have order either 1, 2, 5 or 10. Other than this, element cannot have that order. We cannot say that element of order 6 will exist in the group of order 10. Is it clear?
Yes, sir.
Yes, sir.
Okay. Okay. So till now it is going very easy. Okay. Are you comfortable with this till now?
Yes, sir.
Yes, sir.
Okay. Okay. So this you already know phi of D. Like if G is a cyclic of order n, if D divides n, then there is exactly phi of D elements of order D in G. Lagrange's theorem is reverse is true in case of cyclic group. It is not true in case of any general group. It means that if some number divides order of group, we have element of that order in that group. Okay? Yes?
Yes, sir.
Yes.
Yes, sir.
So Lagrange's theorem true for cyclic group means reverse also. Okay? In general, one way it is true for all groups.
So
Clear?
instead of cyclic, we can also say it is true for abelian group.
It is
Finite
true
abelian.
for
Finite
finite
abelian.
abelian group. Finite abelian groups. Finite abelian groups, it is true for it is true for finite abelian group. So can we have abelian group? Like then we have to say the proper divisor in that. Hello, someone asked the question. Now, hello. Yes, someone says that it is true for abelian group, correct? Converse.
Yes, sir.
Yes.
Yes. Yes. So in the abelian group, when we say that every divisor, then we should say that it is proper divisor, correct? Maybe suppose order is abelian group, right? It is abelian, not cyclic. Hello.
Yes, sir. We
We
are
can
listening.
have discussion. Yes, yes. So 10 divides 10, correct? The notation is like this: A divides B, correct? So can we find an element of order 10? In the group which has order 10? Yes or no?
If we get
No, sir.
order of 10, then it should be cyclic group.
It is cyclic, right? So converse is true, correct? But This question may confuse, like later on you will give the net exam. In that, every word is important. We have to read the question carefully. If it's a proper divisor, maybe I will also check with this definition. So if it is true, then it should mention it is proper divisor. Proper divisor means then you can say like 1, 2, 5. It may have. Okay. So the focusing word which I am saying here, proper. Yes. Is it okay?
Yes.
Proper divisor means the number is not equal to that number. Okay. Thank you. So fundamental theorem, like every finite abelian group, you can break it. I will send this PPD to all. Now, what does it mean that suppose this is Z10, it is abelian group, yes or no?
Yes, sir.
So I
Yes,
can
sir.
write in Z2 cross Z5. So in simple language, we can say that any abelian group, it should be finite definitely, we can break into the other groups. Correct? We can break into the groups. And one more also thing that we can break into the group and that every group has order of prime power. Like here, I have only the prime number 2, 5. Correct? If I want to write Z2L, I can write Z2 square into Z3 also. Correct? So it is power of prime. So every group, not every group, finite group, every finite abelian group can be decomposed, or you can say you can break it into a group. Okay, this is called cross product. So we can break into group and every group has order prime power. And where it can we can use this in this form, that Zm cross Zn is cyclic. Now this is one rule, result. If and only if this M and N. Now if M and N co-prime, means GCD between M and N is 1. Okay, GCD between M and N is 1. So if it is abelian group, and if you can write in form of Zm cross Zn, where GCD of Zm M comma N is 1, then you can say it is cyclic. So GCD of M comma N is 1. Then this breakup which we have done Zm cross Zn, this whole group, suppose this is G, then G is cyclic. Clear?
Yes, sir.
Sorry. Okay. Now, the underline sign which I'm making, this is also a result. Abelian, first off, which we say that every cyclic is abelian, but every abelian is not cyclic. Correct. But if we know the abelian group and if we break in into Zm cross Zn, where Mn and GCD is 1, then we can say yes, it is cyclic. Again, the next property in example second, which is given, if we can break into 2 power P and Q, and if the less number divides, suppose P is less than Q, if it does not divide Q minus 1, then it is a cyclic. It should not divide Q minus 1. Then it is a cyclic group. So this is result. Okay. Okay. So same order, different structure. This all things like I'm leaving now. Till now, what is we have done? Can anybody explain or just discuss into 1-2 minutes? And I will write here whatever you say.
Yes, sir. What are you asking for?
I am asking till now what we have done.
Yes, we have. Am I audible?
Yes, you are audible. Yes.
Yes, yes. We have up to now we have given definition of group and what are the axioms of the group and order of a group and certain
Okay, order.
properties.
Okay.
And
Okay. Any other student now?
We have discussed cyclic groups, abelian groups,
Cyclic, abelian,
order of a
abelian
group.
group, order of element. Okay. So how I can calculate order of element in cyclic group? Like order of, suppose A, or any order of A in a group.
We will take
Formula.
GCD. When
So
we
it is
get
n
one,
upon GCD. GCD of n comma k, correct?
Yes, sir.
That is the number of element we can calculate. Okay. That number of element of order A. Correct? I can go back. That is also true. Order of element A bar is n upon GCD of AN. And number of element also we can check. Okay. Now, we will jump for the questions. Okay. So this homomorphism will do for later. But one thing we can say that if we have any cyclic group of order 10, for solving purpose, we can take it is Z10. Any cyclic group of order n, we can consider it is Zn. Okay. So it makes simple to solve the questions. Any infinite cyclic group, we'll consider it is Z. So there is isomorphism between Z and any infinite cyclic group. There is isomorphism between Zn, means finite cyclic group, to other group who has order n. Clear? So when I say infinite cyclic group, we will take Z. And whenever we have a finite group, finite cyclic group of order n, that is, we can take Zn. Then we can, because if we take Zn, then I know all the elements in Zn. And whatever true here, it is true in the general group of order n, which is cyclic. Clear? Okay.
Yes, sir.
Good. So now by the end of this lecture, what we have done, we just have done definition of groups, some example, non-example, order of group, order of element, cyclic and abelian. Whatever you have said, it is the same thing here. Correct? And last I told that all cyclic group are same as order or isomorphic to Z infinite or Zn if it is a finite case. Okay. With this concept, I want to tell you that to solve the questions, there are many concepts is required. In one question, it is not like just only one or two concept is there. Mix of questions, a mix of concept is applied to one question. Correct? 2 or 3 concept, 4 or 5 concept is required for one question. Number one. Now, to solve, like we have only 2 months, we can neglect the proof of any results, but the result which we are writing, we should sure that it is true. Either it should be taken from some reference book only. Okay. We can just remember the result. We will use as a tool. And if we have time more, then definitely we can go for the proofs. Now, when the question which you are going to solve ahead, it may require more concept than which we have discussed now. So if we know it's okay, we don't know, we will discuss then while solving the problem also. Okay. So till now, any questions from any students? Dear aspirants? No question? Can I go ahead?
Yes, sir.
Yes. So actually this the question means it's for both us. You can ask me question. If you are not asking, then I will ask the question. So this is question number 9 from 2025 paper. First of all, when we see the question, we should read carefully every word, and which we feel it is important, we can underline. Reading the question is very important. And then accumulate the data which is there. हमें वो डेटा पूरा समझना चाहिए कि क्या है, फिर सॉल्व करेंगे. अगर टाइम है तो करेंगे, नहीं तो अगले क्वेश्चन पे भी बढ़ सकते हैं. एग्जाम में भी ऐसे स्ट्रेटेजी हम अपना सकते हैं. So let G be the finite abelian group of order 10. let x naught be element of order 2. Then it means that order of x naught is 2. X naught square is identity. So I have written till here. And whatever I have read, I accumulated this data already. Now, if x is equal to small x belongs to G, such that x cube is equal to x naught. Okay, it means that x is from G, definitely because G is a bigger group. But the condition main is x cube should equal to x naught. Okay, so I digested this data. Now, definitely we don't have to solve. Answer is in between these 4 option only. So we have to find out the answer. We don't have to solve and get the answer. Correct. So XX exactly 1 element, 2 element, 3 element or empty set. Clear? So when we have 4 option, one way either I can neglect this, means I can discard the option by some contradiction or some with the example, or I can go for the answer directly. Both trick works here. Now, first thing we know when we write x cube equal to x 0. Now, can you tell me what is the first thing, like what it comes on mind by reading this question?
So we need to find
What I should
such
do
element.
first?
We need to find such element in group having order 10, which we operate 3 times. We get x naught, that is, which is equal to having order 2.
Correct. So this is the question only you explain. Now, when I write here, what is first, what you will do as a first step?
First, we will calculate the order of x.
Order of
By
x.
x to the power,
Okay,
we can
good.
operate
So
it
I
2
can
times to
calculate.
get identity.
Very good. So I can take both side square, correct?
Yes, sir.
Very good. Both side square means I am operating x cube with x cube. Correct? And which is same as x naught, so I can operate 2 times. So the behind the concept I mind, it is operating 2 times the same element, but we can do. So what is this? X raised to 6, which is equal to
Identity.
identity. Okay. It means that order of x will divide 6. Is it true or not?
Yes, sir.
Correct. Because order can be 6 also, because we are getting identity, but we know the order is the least element, least number whose power is identity. Okay. So order of x divides, or I can write order of x in this way in bracket divide 6. So which is the number which divides 6? Tell me.
1,
1,
1, 2,
2,
3, 6.
3, 6. Correct? Now again the concept comes. Which is possible now?
1 and 2.
No, 2 and 6. But here, if 6 was the order of element, then it should divide the 10, but it is not the case.
Very good. Because till now I have used only this data in bracket. I have not used this data also, 10, right?
Yeah.
Correct? So I have not used this data now, 10. So I can say here that yes, 10 order of elements should divide order of group, because we have just learned now. So every number should divide 10, right? So 1 divides 2, okay. 10, 2, okay. 3, no. 6, no. Correct?
Yes,
Yes
sir.
or no?
Yes.
So we
Yes,
got
sir.
that order of x here should be
1 or 2, 1 and 2,
One or
1
two.
or 2.
1 or 2, correct? But is
But
it 1?
but 1 is not possible because order of a group, there are only one order of group, is that identity, but identity is not the case. So I think,
Very good. Identity is not a case, because identity cube will be identity. And identity, cube is identity, then it should be equal to x naught, but not possible because x naught order is 2.
Yes.
So what is the order of x?
2.
2. Very good. Very good. So we have order of x is 2. Correct. Now, but do that we have to find here. क्या हमको वो ढूंढना है?
How much element are there of order 2 in the group of order 10?
So now my question is reduced here, that how many element of order 2 is there, correct? Yes or no? Yes.
sir.
Yes, sir.
Correct. Now I will use this data. Abelian group. We have not used till now. Correct? Do we know any abelian
Yes,
group who's of order 10?
It is Z10.
Yes, sir.
Z10. Z10 and this Z10, any abelian group of order 10 is Z10, that is correct. And we just learned now that any abelian group can be break into two groups.
Yes, it is Z5 cross Z2.
Z5 cross Z2. And also we know that Z5 and Z2, this 5 and 2 GCD is 1. So it will be cyclic.
Yes, sir.
Because any group, now I am not writing Z10 first. I am writing G is equal to Z5 cross Z2 because I use the concept that any group of order 10 can be break into some parts. And that part is now Z5 cross Z2. Is it clear?
Yes, sir.
Now Z5 cross Z2 is cyclic. Is it clear? I said so many corollary
Yes.
theorem by words. So you have to write. Because M and N GCD is 1, that's why it is cyclic. So if it is cyclic, then any cyclic group of order 10 is isomorphic to Z10. Yes or no?
Yes.
Yes. It means my question reduced to solve or to find out number of element of order 2 in Z10. And Z10 I know 1 to 1, 2, 3, 4 up to 10. So how many elements are there of order 2 in Z10?
1.
One.
One only.
1 element. Because. So this is the answer. Understood? So
Yes,
in
sir.
this question,
Yes, sir.
we use so many concepts because it is IIT Jam, right? So we use so many questions. And to apply so many concepts in this type of question, how many marks you will get, you know?
1 or 2 marks maybe.
Huh?
1
One
One
or two.
marks. 1 mark. So it should be very quick. We have taken the time, but if you practice more, you can solve fast. This is question number 9, correct? So our syllabus is designed in such a way. Let's discuss means I have to solve that working which I have shown here. I should have done here, but okay. So 1 to 10 question, you know, it is for 1 marks. You remember this, huh? Means you see the paper, you will get to know. 10 to 30 is for 2 marks. Okay. So,
Yes,
and 31 to 40, it is again 2 marks, but it is MSQ. And 40 to 60, 40 to 51 marks, net numerical type. And 50 to 60, 2 marks, net. So here you have negative marking. My writing is bad. This I have just written. So whenever 1 to 10 question number comes, no, you think it is for 1 marks. So it is question number 9. So it is 1 mark. Okay.
Yes,
And
sir.
no negative, and no negative marking for net and MSQ. So after 30 question, you don't have negative marking. Okay. So this is the explanation, but this is in abstract way. You can see later. Okay. Now next question. It is again 39 number question. May 2025. I want you to attempt because no abstraction here, no group G, nothing. All thing you know. What is U8 you know? It is given Zn, right? Zn with multiplicative operation is multiplication. Un is this, which GCD is 1. So all invertible element multiplicative inverse which exists from Zn, that only element has taken. So it is 39 question. It means it is MSQ question. So in your mind, you think in exam also, if you see the question, it is not written after 30 question. Means when you attempt 30 question, after that 31 starts. It doesn't write over there that it is MSQ. So you have to read instruction on first page and then you can. Means in PDF actually. I don't know CBT computer based system in PDF. So it is MSQ question. Now solve. MSQ means 1 or 2 or 3 or 4. All options can be. I am giving 2 minutes. You can put in the chat box your answer. I hope you know U8, U5, U12, U9, all the elements in that. Hello.
Yes, sir. I think I'm checking.
Okay. Okay. Good.
Sir,
Yes, ma'am.
is it U5 is cyclic group? Because Z5 is cyclic group
Hmm.
and GCD of any number 5 is a prime. So it gives 1. So UN equal to U5. So it is also cyclic group.
Good. Okay. What are all the elements here?
0, 1, 2, 3, 4.
So actually Z, when you say prime, so Z5 is cyclic. But U5, we have to check. What is the order of U5? And what is the order of Z5?
U5 order 4.
And order of Z5?
5.
5. So Z5 is cyclic because order is prime. U5, you cannot say that because it is prime and no, because this order is not a prime only. Hello, got it? So our means maybe you are correct, it is cyclic or not, but the reason which you gave, it is not correct. I hope I make sense. Hello? Someone asked about U5. You can unmute and ask.
Sir, I think C, D, and A will be. Sorry. I think U5 is not correct, but U9, U12, U9 is cyclic.
Okay. So, okay. So now it's time is over. Already 3 minutes we have taken. So U8, U5, U12. So U8, which element will be there in U8? All those which are co-prime with 1. All those we are co-prime with 8, right? Because GCD is 1, right?
Yes,
So tell me the element 1,
3,
3,
5,
5,
7.
7. Correct?
Order is 4.
Huh. So they are saying it is cyclic group. What is order of 1? Order of 1. Okay. So I should have one element whose order is 4, right?
Yes, sir.
Cyclic means
Yes,
order
sir.
group is 4. That is true. But cyclic means what? I want one element whose order is 4. Yes or no?
Yes, sir.
Yes,
But
sir.
there does not
Yeah, we will
exist
check in this way only. We'll not say order is 4 then check. No, we will check. So what is 3? It is multiplication. We have to operate. 3 square is 9. 9 modulo 8 is 1. So this order is 1. 5 square 24, order is 1. 7 square 49, order is 1. So this is not cyclic. Correct?
Sir,
So
order is
you
2, na?
2, 2. Yes, order is 2. Order is 2. It is not
Yes,
4.
yes,
So it is not cyclic. Correct.
yes.
In the
so
same way, we have to
U9
check for.
will
Huh?
be correct
Huh?
because so U9 will be correct because the order is 6 and we can write 6 as a product of 2 into 3.
Correct. Okay. So that is okay. Very good. And U5?
Order is 4. So it it won't be.
No, it is not like that. Order 4, then it is not a cyclic. It may, no. What C said
Sir,
one student
Q5
asked.
has an element of order 4, 2.
We have to check. So we can check 2. So multiply with 2, it is first 2, then 4, then 8. Correct? So 8 modulo 5, we can say in with terms of it is a multiplication, then it is 3. Correct? Yes or no?
3 times 2 will be 6, which is
And
modulo 1
3
will be
into 6
1.
is 6,
Modulo
modulo
5.
1. So this is order 4. Correct? So U5 is cyclic. Correct?
Yes, sir.
So what the previous one said, she said correctly, it is cyclic, but reason was wrong. Oh, not correct. Okay, now C part, U12. Yes, tell me the element.
So 1, 5, 7, 11.
1, 5, 7, 11. That's it. So what is 5 square? 25, 1. Correct. 7 square, 49, 1.
Yes, sir.
Correct. And 11 square, 121. So it is 120. Correct. So every element has order 2.
Yes.
Yes, sir.
So if every element order 2, what the type of that element is called? Means what type of group it is? In order.
Abelian group.
Planes group.
That is also true. This is abelian group. Okay. Okay. Good. Okay. So B
Yes,
and
sir.
D. And you can check here B and D. And this is for 2 marks. Okay. Because 39 MSQ.
Sir, in MSQ, if I correct, if I put one option correct, but it is assigned as option three option is correct, but I choose the one option of them correctly, it will not no marks.
Yeah, 0 marks.
Yeah.
You have to mark all correct option. Partially marking is not there. Okay. And it is good, like no negative marking also. So you can attempt. And it carry 20 marks MSQ. 1 marks are easy. So your question was whether you will get partially marked? No partial mark.
Yes.
You will get 0 marks. No negative also. So that is thinking process. You have to think all 4 options, check correctly. And if it is correct, okay. If not, then again think, find counter example. Okay. Good. This question, maybe numeric type, maybe, yes. Question number I have not written, but numeric type maybe. Let G be the abelian group of order 35. So whenever I have abelian group in my mind, order 35, yes. First theorem, fundamental theorem. Like I will break this. Like I will not write Z, I will write G
5
is
into
equal to.
7. 5 into
Very
7.
good.
Z5
I
into
can write
Z7.
into Z cross Z into Z5. Can I write this?
And 5 does not divide 7 minus 1. That is, it is cyclic.
Oh, very good. Shabash. So it is cyclic. Okay. Now let M be the number of element of order 5 and N be the number of element of order 7. Correct? So number of element of order 5. Someone has already said it is phi of N. I hope you remember.
Yes, sir.
So
Yes,
number
sir.
of element of order 5, it is M. So what is the number of element of order 5?
4.
Very good. And what is the number of element of order 7?
6.
6.
6. And what we have to find out here?
It's 10.
M plus N. Find M plus N. Find
is
M
equal to
plus N. So 4 plus 6,
4
this
plus
is equal
6.
to 10. So this is
10.
NAT question. So actually this is question number 60 or 59. Question number 59 or 60 in 2025 exam. Okay. So after this, let's discuss the solution. It is 10. Very good. You got it correct. So now it is 2024. When I say that 2025 and now we are in 2024, it doesn't mean that we solved all the question based on the group theory. Okay. We have solved 5 questions maybe. But there are the questions on topic group theory in May 2025 based on normal groups, permutation groups, others concepts which we have not touched today. So if we go in next class, maybe if we do permutation group and other thing, definitely we will do. Then again we will start from 2024 only or 2025 only. Okay, back. So this question, let G group of order 39. And what happens when it is given Z and Z something, then our mind works. Okay. But when it comes in abstract way, let G be group of order 39, then okay. Then we lost somewhere. Order 39. So I underline this main important one 39 such that it has exactly one subgroup of order 3. One subgroup of order 3. Okay. And exactly one subgroup of order 13 also. Exactly one. So which of the following is true? Okay. So this concept requires Silo theorem. Without that also we will do Silo theorem. This is your homework. You read. It is not given in syllabus, but with this we can solve questions easily. Silo theorem. You read and we will meet in next class with this theorem. Okay. Homework. This is your homework.
Sir,
So if it is
if we don't know the Silos theorem, but without Silos theorem, can we try to solve this?
yes, we
Sir,
can do.
one thing is order 3 and 39 is 13 cross 3. It is cyclic
You are
necessarily.
saying that. No, see. Oh, when you say I got it. You want to break into like 13 into 3, correct?
Yes, sir.
Yes. When you will break this? ये आप कभी तोड़ सकते हैं इसको जब
If it is abelian.
हाँ जब वो ग्रुप abelian हो correct when the group is abelian here is not given that G is a group or it is abelian maybe later it will come but it is not mentioned here that G is the abelian group. So when you are applying some theorem some rule we have to check that it should satisfy the given data which is mentioned in that theorem और इन दैट कोरोलरी कुछ चीजें उसमें दी हुई है तब जाके कुछ चीजें उसमें संभवतः पॉसिबल है तो हम क्या कर रहे हैं जो पॉसिबल है वही ले लेते हैं नहीं हमको पहले चेक करना वी हैव टू चेक दैट वेदर दैट इज एप्लीकेबल और नॉट सो इज इट नॉट ग्रुप सो यू कैन नॉट अप्लाई दैट थियोरी अंडरस्टूड क्लियर
Got it, sir.
हाँ so silo group says that it comes under normal group okay so we know coset group we know normal group yes do we know normal group
Yes, sir.
Yes, sir.
So if H is a normal in G, and if it is unique, in that case we can use silotheorem. So it is there exactly one subgroup of order 3 and exactly one subgroup of order 13. So it has only one group, that is okay, unique. And it is normal also because G by H, when we write, suppose order group is 3. Suppose I am writing G and H. Suppose order of H is 3. So what is order of G by H? What is the order of this coset G by H? Can you tell me?
Order of G by order of H.
What is that? I am saying order of H is 3. Suppose first thing 3. Order of H is 3. So what is order of G by H here?
13.
39 by 3,
13. 13, right?
13.
So it is prime. So now again, some concept, some theorem. If G by H, now it is prime, right? It means G by H is cyclic, right?
Yes, sir.
Yes, sir.
G by H is cyclic. So if G by H is cyclic, then H is a normal. Oh, H is normal. So if H is normal, and already it is given, it is unique group. Only one group. And also, other group is also one group, 13. Correct? Because G by H2 if I take, and if it is 13, it is prime, so it is cyclic, it is normal. So what I am using, I am writing here, G by H is cyclic. Then H is normal. You got my point? So I'm writing and I'm saying the word also, so that if you don't understand my handwriting, because this writing pad I'm not used so.
If we are quotienting G by H, then it is we assume that H should be normal, and for
No,
that what?
no, we have not assumed here H is normal. Till now we have not assumed.
But how can I define G by H is a group? Then we can talk about if we are not sure that H is a normal subgroup, then we can write it about
Okay.
coset.
Yes, I got your point. I got your point. What you are saying that we cannot write G by H unless the H is normal.
Yes.
Correct?
Yes, sir.
Yes. So the theory it says correct. But I'm just asking that here, so it is not defined. That is true if it is not normal. So, but if G by H is cyclic, means order. I'm asking about the order here. Okay. So order of G by order of H, if I take, these two numbers are defined always. Clear? Good question you ask. Order of G and order of H is this two number is defined. Correct?
Yes.
Yes. So this number which is coming, it is cyclic. So then without checking also we can say that H is a normal in G. So I'm going in the reverse way. I hope you I make sense. It's clear. So you are correct. I should write here order of H divided by order of G. Okay.
Yes.
We will discuss this more also. This theorem I will write in a perfect way and I will tell you. So if this is cyclic, if this order is prime, then H is normal in G. So we have unique group H and unique group K. So till now I am assuming that both are normal and in one group exactly. Then G can be written as a cross product of these two group H into K. This is the Silos theorem. So Silos theorem is homework. You read this and again you see this the same question after reading this. Okay. So now this we can write in cross product of H of K. Now we can write instead of if G is abelian, then directly we can write. But Silos gives for non-abelian group also this decomposition. So it is order 3 and it is order 13. Correct? Like H cross K. Now this becomes a cyclic group. Because 3 into 13 the GCD is 1. 3 and 13 the GCD is 1. So in this question,
in the very beginning, I have assumed it is abelian, and that is why I am getting
correct, good.
the 13. It
Yes,
is
yes,
the original reason. If I would assume that it is abelian, then I would get G is a option as a correct, but it is logically wrong.
Yes, either intuition says that and it is correct, but in exam many times it may be wrong also.
And it
Your
is
logic.
it is a cyclic group via internet direct product using via internet direct product and Seller's theorem.
Yes, yes,
It is
yes, yes, yes.
sir,
Correct, good.
yes,
Uh,
here exactly one subgroup of order 3 and exactly one of order 13.
uh,
That is why when we exactly one silos P group, it should be normal. That is why G by
mhm.
H is defined here.
Yes, 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 yes. Yes, that is also correct. Means one subgroup, then it is normal. Yes, unique subgroup, it is normal. That is theorem, correct. And this is also the result. If G by H is cyclic, then H is also normal.
Yes,
This result I have to check. Correct. So if it is exactly one, it is normal. That's why it is G by H is defined. Exactly one, it is a normal. That's why G by H is defined. So sorry for that. I have taken this goal हुआ इसमें. But G by H is normal. So and it is unique group. We can write in the decomposition form. So here, yes, G is a cycle group. G is abelian, but need not be cyclic. Is it true? Second option.
No, sir.
No. Third.
No, sir.
No. Fourth.
No.
No. So G has 13 element of order 13. So instead of this, what should be there? G has how many elements of order 13 then?
12.
12. Very good.
12.
Very good. Very good. Clear. Thank you. So in this question, we learn like silo groups and the theorem which I was reciting. But it is already there that instead of going in this way like G by H is cyclic and H normal, that we will see. It is given that one. So this one is important here, that if you have unique silo group, then it is a normal of that order. Correct? Silo group means
Yes,
order
sir.
P raised to K. The order, the group, we said is silo P group. P raised to K plus 1 should not divide that order of the group. Correct?
Yes, sir.
Highest order, that is. Okay. So it is question 5. So it is definitely one option is correct. Okay. Now, yes, option A is correct. We can write in this decomposition cyclic group of order 3 cross cyclic group of order 13. This question I want you to try.
Yes, sir. I will. We will tell in the next class because I have a doubt in such type of U of something and their
Uh,
properties. Sometimes,
mm.
sometimes it is coincide with the p prime number of element of un, which is prime. Then it is easy to understand. But sometimes it is difficult when n is not prime. U of
Okay,
n
so
that
let discuss. It will take only 2-3 minutes. Let's discuss now.
okay. Okay, we are
I-
trying first 2 minutes, 1 minute, and then
Okay, you try. But you said you have confusion, so let's clear that confusion first. Means how to write U5, how to write U8. You
yes,
know that.
yes, sir.
If you know, then write the element. Okay. See, I have also written my set of elements. Check, is it matching with you? If it is not matching, it is not like that you are wrong. I may also be wrong. Is it true? Correct?
U12 will be 1, 5, 7, and 11.
11. Very good. So it is 11. So we have checked already that U8 was all element order 2, correct?
Yes, sir.
Yes, sir.
We have checked U12 also as element of order 2. So the student which one student was saying that, sir, I have confusion in this. If the
Yes,
listing
yes.
of the element, so I am saying, is the problem in the listing of the element?
No,
No,
listing of
okay.
the element.
So you don't have a problem in listing of the element, correct? आप ये
Yes.
लिख सकते हैं एलिमेंट को. प्रॉब्लम
Yes.
क्या आता है कि ऑर्डर फाइंड आउट करने के लिए कि हाउ आई कैन चेक, राइट?
Yes, sir.
So just
And
take now you, yes, yes,
yes, and in this case, all of our cardinality same 4.
yes, yes, yes. So now see, we will check element order. Okay. So
Yes.
suppose that 10. Here you keep in mind we are doing multiplication. What we are doing?
Multiplication.
Multiplication, not addition. So it is 3, right? So first you write 3. Then multiply 3 with 3. It is not a plus a. Multiply 3 with 3. So what we will get?
9.
9. So I will write 9. Then again multiply 3 with 9. So what you will get?
27.
27 modulo 10. How much it is?
7.
7.
7. Then again multiply 3. How much is?
1.
So again you multiplied with 1 with 3. What you will get?
1. It is the element of order 4.
Correct. But if you multiply 1 with 3, then you will get the same number. So you will stop
Yes.
here. Correct?
Yes, yes, yes.
So now you have one element,
Of
3,
order 4.
order 4. It means that U10 is cyclic.
Cyclic. Yes, yes.
So you know, yes, U10 is cyclic. But in the same process, if you do in U8,
Then
what is
it should
3
be
into 3?
cyclic. It should be cyclic. Due to isomorphism, it should be cyclic. But
No. You see, first you check. It is not due to isomorphism. If both are cyclic, then it is isomorphism. If it is isomorphism, they both are cyclic. So till now you don't have anyone. You neither have U8 is cyclic till now. You have to check, right? चेक करो अभी यहाँ पे 3 का स्क्वायर कितना
sir,
है?
you have told that we have checked for U8 all the element of order 2. Then how can it be cyclic?
So it cannot be cyclic, correct?
Yes,
So
yes,
U10 and U8 are not isomorphic then.
Yes, yes.
This is not isomorphic. You can
Yes,
say
yes.
U12 now. In U8, all element are order 2, correct?
Yes, sir.
In U12 also all element. What is the order of 5 here in U12?
2.
2. 5 into 5, 25. So it is modulo 12, 1. This is 7 square 49, right?
Yes. In
And this is
U12
also
we have
11.
all other.
So it means that U8 and U12 are isomorphic because in both the set, all elements are order 2. Understood?
Yes.
And U5 and U10 is isomorphism because both the set are cyclic and same order. So same order cyclic group are isomorphic to each other. Clear?
Yes, sir.
Now what will be the option?
And D.
D. Very good. Very good. Okay. So till now, you can check that 60 questions are there in the exam. You can put the timer also while solving the problem. On an average, definitely all 60, if you attempt, it is and all are correct, it's not possible. Means if we are very good, then definitely it's possible, because 100 marks question, all 100 getting is means a very big day. So if you aim till 60, 70, 80 marks, correct. So we can have to divide our time in that. If 60 question, 3 hours timing, right?
Yes, sir.
Yes, sir.
So one question, how many minutes?
3 minutes.
3 minutes. So in three, if not time all question. If not, if you're taking 5 minutes, it's also okay. But don't take more than 5 minutes while solving. So what I will do, today I will stop for here. But there are more questions from 2024 on the topic order of element, Lagrange theorem. But just finding the question which is on order of element does it is difficult, because so many other concepts are also included in that. So that's why while solving the question, I was getting into discussion of the topic concepts also. We can have the questions just on order of element, but it will be easy, and exam type it is not there. And that topic questions you may solve if you have time, but that will not build confidence to solve this exam type question. And we have less time, so that's why I will suggest and recommend that directly jump to the past papers. I will send one link, or you can also download from 2012 to 2025 paper from IIT Bombay website. You can directly type in the Google IIT Jam 2026. First link you click, or I in my link which I have shared that day on my Google site, you can click. You will get all papers. Answer key may not match. I don't know. Answer key is also available that you can check. Okay, 2012, 14 it was descriptive also. So from 16 you have this objective types question. 2016. Okay. So I will stop here for now. This rest question I will upload on that same site. You try, you see, and also the assignment on this first lecture. I will pick the question which we discussed. I will pick the question which is based on the topic and the concept which we did today. Okay, is it fine?
Yes, sir. It is
Yes.
very,
Yes, sir.
very good after good thing.
Okay. Yes. And last thing I want to tell you that, because see, I have made some strategies, but the strategy which work, it is not at all a part of a strategy. So कभी ऐसा होता है जो आप प्लान किए वो नहीं होता, और जो प्लान जो चल जाता है वो प्लान में भी नहीं होता. तो मैं ये चाहता हूँ कि आप मुझे सजेशन दीजिए कि हाउ द क्लास शुड रन इन द नेक्स्ट 3 classes, and I will incorporate that. So like give me some feedback, positive, negative, whatever it is. Now verbally or writing message, or verbally also you can say. Don't be shy.
Yes, sir. If the recording is stopped, then I can ask a question related to this, but it is a quite not direct question. It is a strategy related. So if the authority will stop recording, then I can proceed.
Okay. Ma'am?
Yes, sir.
Yes, ma'am. So for today, like I'm stopping, and student have some they want to discuss something now for some questions. So they are requesting like, can we stop the recording, and he want to discuss something.
So why the recording needs to be stopped? He can ask the question like this only, no?
Yes. Okay, ma'am.
Okay, thank you, ma'am. Sir, I am asking you particular in case of revision, what we are in whom we are doing. One thing is attempting the PYQ with a limited stipulated time reference, as we have done in all of these questions you have picked out. But sir, in what is this proper way of revision? Suppose you have referred a book. This is the Contemporary Abstract Algebra by Joseph Pagelian. So How can we revision this book in the regular interval, or in each time should we attempt a new type of problem? I think there are so many combination of problem on the known topic that we have, as we have the limited syllabus. But how can we practice in general from this exercise of this book, particular book or whatever book we have read uncomfortable to? So please,
Actually, sometime what strategy when you are asking, so it is what suits you, right?
yes,
So,
sir.
so and depends upon what is our level now. If now 2 months exam is there, so till now we should know the concepts at least, the
Yes, sir.
definitions, and the all the examples. Okay, so if we know this, then after this the strategy maybe uh, you can think of, which I suggest, and I also did in my during my net exams. So in whole Galleon book there are theorem and corollaries. I have written all theorems and corollary. Proof I have not like written. I do not remember also. I can't prove the theorem and corollary, but I know the statement very carefully. Like I told you that let G be the abelian group, this and that. So
Yes,
I
sir.
have listed down all the theorems and corollary in page, maybe 2 pages. But if you take all the thing, real analysis, linear algebra, algebra. So now we are on the algebra. So you can write for the algebra, but we should do for all. Okay,
Yes,
so there
sir.
will be one issue.
My point is revision not only for your topic but also rest
Yeah,
of the
yeah,
topic. Yeah. It is
yes,
a your
yes.
opinion and
So
suggestion.
you, yes, so you can prepare one small booklet for you, where all the theorem, all the corollary is written, correct?
Yes, sir.
And you can refer while solving this paper. Maybe now the next question which you asked about the stipulated time, you forget
Yes,
about the
sir.
time. Don't keep now timer everything. But the question which you pick from like question one, you go by line wise only. You pick suppose question one, you see, and first we should know that it is from which topic, right? So you can have a real analysis, your notes already written, or linear algebra group theory. You can see the read the theorem. Oh, I can apply this here. Then you can apply and solve this. Okay, this is one thing. Second, write down all the counter examples. The group which is cyclic but not the group which is abelian but not cyclic. So you know Klein's four group,
Sir,
and we know
uh,
that U8. So all the counter example you write it down.
sir, it is the I think when we solving particular problem and first time we did it wrong, but but secondly, if we get the correct answer uh, or any counter example from some source, whether it is internet or something or from teacher or other student, then simultaneously maintain a notebook of our own preference. That is should be noted this example for the quick revision of later time. Okay, otherwise it
Mhm.
would get lost or in mind because counter finding counter example with limited time, it is seems difficult
Yes,
sometimes
yes, sir. Yes, yes. We should
because
write all the counter examples and
yes,
some small booklet. That's it.
yes,
And practice more problem. Like you have 60 questions in this year.
yes, yes,
Last
sir.
5 year at least you solve 60 into 5, 300. 300 questions, right?
Yes,
So it is okay, 300 question. But in that one question, two, three concepts are involved. It will take time.
yes,
Uh,
sir.
it will take initially it will take time, but slowly and gradually all this theorem corollary will fit in your mind. And whenever you see the question of that particular type in your mind, you will pick directly that theorem and you can apply. You will apply.
Okay, sir.
Okay.
And sir, I will want to ask also from this book, particular this book you have chosen for us.
Uh,
Can we ask in your Telegram group about not about solution, but if my thinking or approach whether it is wrong or right, particular for this book only, because we have not solved yet due to semester work. We have solved others book.
okay, you can
Okay,
you
okay,
learn the concept. Yes.
okay,
The
sir.
if you want to ask particular question from this book also you can put in the group. But
Okay, sir.
basically the question of this group are like proof type.
Yes.
So it is group theory, proof type question, proof this, proof that, that type of question is there. So that also we can discuss. But now we are focusing on IT jam question, where the time is important. You should learn the concept, you to apply in the question properly. And it is not like that if, even if we know many things, we can do good in the exam. Presence of mind during solving the question is also important. Students who are very talented in exam, they lost. So presence of mind is also important.
Yes, because short
Correct.
thing
So,
are
so we can, what you said, like if you have doubt in the from that book, also you can put in the group. Even if not me, then other students who know, they can also solve. But if it is question from jam, then
yes,
definitely I will answer.
yes, sir.
Hmm?
Okay, okay,
Okay.
sir.
Okay.
Okay.
Okay. Thank you.
Thank
Any
you,
other
sir, for
questions?
no,
Thank you.
sir. Thank you. Thank you for such
Thank you.
engaging
Next.
session and
Uh,
so
uh,
interaction, deep
oh,
interaction.
oh,
Okay.
thank you. Actually, I wanted the feedback for me, but maybe later it will there. Or you can put in the
Later.
group how, or you can put in the group like how the lecture should go on. Okay.
Okay. Okay, sir.
Okay.
Hello,
Thank
sir.
you. Yes, sir.
Sir,
Yes.
sir, can you tell us which section should we attempt first? Is it MCQ or MSQ or NAT type question?
Uh, it depends upon person to person. For me, I will go for objectives first only. And
MCQ.
it is so it depends. Like first, if the paper got to you, it is not like hard now, right? Correct. It is like computer based system. Correct, no?
Yes,
Used to
sir.
have that pen, so you can glance the whole questions. Tuck, 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 tuck. Instead of going in section like objective and net type, numerical type, you choose the topic in which you are strong. If you are strong real analysis, then first attempt the topic question from the real analysis. If you are strong in algebra, then go with the algebra. So I will suggest not to go with the type of the question, but rather to go on the topic wise of the question, which in which you are strong. So it will give you confidence that yes, I'm strong. So I'm strong in group three. I will first attempt all group three questions. Or in
And
algebra, all.
sir, I think during exam last time of after something 1.30 1 hour 30 minutes later, when the time will increase, we are getting more confused. So that is why we should put the section which are considering negative mark at the very beginning of, because at the very beginning
Yes.
where brain is on more than cool later stage.
Yes, it depends upon yes. So it is like topic also. If you are going for negative marking question like 1/3 and 2/3 also. So half 50% question have negative marking. 50 don't have. But in that the thinking is more. MSQ and net type.
Yes.
Correct. So in that 30 question also, which is negative, you pick the topic in which you are strong first. You do that all. Then in the second section also, you pick the topic which you are strong and which you feel you can do. And last question. So now once you glance all the question in which you are confident, you are sure that whatever I have done, it is good. Again, you can come back to the question which you have not done. Then two or three, maximum three. When two part, you can solve all questions.
Okay, sir.
Okay. But strongly, I said, don't go with top type of the questions. If you go for topic, then it is good.
Okay, sir. Thank you.
Okay. 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 Ma'am?
Okay, yeah, I hope there are
Yes,
no
ma'am.
more questions. As sir has
Yes.
suggested, students, please post your feedbacks and suggestions in the group if you have anything to suggest. Thank you very much, sir.
Thank
We'll
you.
meet
And
for the next session.
one more
Yes, sir.
request: be punctual first, and second, you read something and come. Preliminaries I am already sending, and some self assessment also. You check how much you are getting. If you are getting less mark, means the wrong question. If it is there, then the question which you went wrong, you read the concept again, attempt it. Means जो गलत हुआ है वो आपको सुधारो, आप देख लो उसको, राइट? सो दैट सेम क्वेश्चन इफ appears in the next time, you should not make the same mistake which you have done earlier. So make a new mistake, and slowly the mistake can be reduced. Okay, so whatever mistake done, go and correct it at the time. Okay.
Okay, sir.
Okay. Okay. So,
Thank you very much, sir. Yeah.
Yes, yes. Thank you, ma'am. And last, this is screen. So this is the basic summary for group theory summary for today's. So whatever the definition it was there, it was in just the definition and theorem which I was saying. So I've already written here for this cyclic and abelian. So I will also upload this in the site. Okay.
Okay.
Okay. Okay. Thank you, ma'am. Thank you. Thank you, all aspirants.
Yes, sir. Thank you very much.
Thank you.